A reminder of where we're headed is that there's 4 parameters, A, B, C, and D, that are going to have an effect on our graph. We're always going to have that wavy thing, but A, B, C, and D are going to tweak the wave. They're going to move it around. They're going to move it up. They're going to move it down. They're going to squeeze it. They're going to expand it. They're going to shrink it. So I want to take a look now at parameter B. And so we can focus on parameter B. I'm making the others as simple as I can. I'm making A equal to 1. Because if I made A equal to 0, this would all disappear. So I'm making A equal to 1. Keeping C at 0, it's not doing anything. In fact, I took it away because it's not doing anything. I made D 0 because I just want to focus on parameter B. Now, sine and cosine functions are periodic. What does periodic mean? That means they keep repeating themselves over and over and over again. You'll see the same pattern over and over again. Okay. We have in our real world many things that are periodic. Phases of the moon. Goes from being a full moon to seeing half the moon, then no moon, then the other half of the moon, then back to a full moon. And then we go through again. Half the moon, no moon, the other half of the moon, full moon. Half the moon, no moon, other half of the moon, full moon. We keep repeating that cycle every roughly 29 days. Okay. How high is the sun in the sky at noon? Well, it's going to reach its highest point the first day of summer. Then the first day of fall, it's at its average point. First day of winter, it's at its lowest point for a noontime sun. Then by first day of spring, it's back to the middle. First day of summer the next year, it's back at the peak. And that pattern repeats itself as going from its middle point to high point to middle point to low point. In fact, we can kind of graph that with a sine wave. Okay? Periodic functions keep repeating themselves over and over again. Okay? If you look at where the right hand is, or the big hand is on the clock, it goes from 12, it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I went the wrong way. Then back to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 again. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 again. It keeps repeating itself. Okay. So sine and cosine functions are periodic. Okay. The period of f of t equals sine of t is 2 pi. That's how long it took to complete one cycle. Okay. G of t equals sine of 4t has a different period. That is, the effect that B has, the effect that this coefficient 4 has in front of the t is to change the period. Okay. Note here, as t goes from 0 to pi over 2, 4t goes from 0 to 2 pi. What does that mean? That means we don't have to go from 0 to 2 pi to complete a cycle. we only need to go from 0 to pi over 2. We have key points every quarter period. What do I mean by that? Let's look at our familiar and not so good sketch here of the unit circle. Key points are when we're here, 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 and here. So as I complete one trip around the circle, as I complete one period, I have key points 1, 2, 3, 4 steps every period. 1, 2, 3, 4. Every quarter period. In this case, every 90 degrees or every pi over 2. But now again, this parameter here 4 tweaked the period. Okay. So graphing, I think I called it y, but I'm going to call it now actually better. G of t equals sine of 4t. Here is a key formula for you. The period is 2 pi over b. Okay. In this example, that's going to be 2 pi over 4, which is pi over 2. It's also good to have what a quarter period is. Always 1/4 here. Why do I want to find 1/4 of the period? Because 1/4 of a period, 1/4 of a complete cycle, is where I'm going to hit those key points. So a quarter period is going to be 1/4 times pi over 2, which means pi over 8. When I make my table of input values and output values, I want to pick input values every pi over 8. So again, we don't want to just be randomly throwing 0, 1, 2, 3, 4, 5 into that function and hoping it leads us to how to graph it. I want to pick my values strategically. And to pick them strategically, I want to pick them every pi over 8. So here's what my table is going to look like. Again, I want room to put a couple things before 0. So I'm going to have t, and I'm going to have, you know what, I'm going to find 4t along the way. And then ultimately what I'm after is sine of 4t. So my t values, again, I'm going to have room to put a couple values before this, but I'm going to put in when t is 0, 4t is 0. But now instead of going every pi over 2 here, I'm going to go every pi over 8. So this is pi over 8. And then let me see, 2/8 is called a quarter. 3/8 pi. 4/8 is called a half. So I've got pi over 2. I think that might be enough. I'm going to go a little bit further. 5/8 pi. 6/8 pi is 3 pi over 4. Going backwards here, I'm going to have negative pi over 8. And then negative, well, 2/8 is, negative 2/8 is negative 1/4. Okay. Why did I choose these values? Again, starting at 0, and I wanted to go every quarter period. Why is that? When I multiply by 4, I get magic. These become my nice places to evaluate the sign of this. So now I want the sine of 4t. That's the sine of this guy. And what am I plugging into the function? I'm plugging in these nice multiples of pi over 2. I'm going to have this little crutch over here. No embarrassment in that if you need it. What's sine of 0? What's my height here? It's 0. Again, 4t here, pi over 2. Put that in blue. Sine of pi over 2 is 1. Sine of, I messed that up. That should have been pi. 1 pi. Sine of pi is 0. Sine of, I messed this up badly. Sine of 3 pi over 2 is negative 1. Sine of 2 pi, I'm back to 0. Sine of 5 pi over 2, that's 2.5 pi. I'm back up to 1. And sine of 3 pi, I've gone 1, 2, 3 pi around the circle. My height here is 0. Going in the other direction, if I went negative pi over 2, my height would be negative 1. If I went negative pi, my height would be back to 0. Okay. How do I want to label my axes? Well, now I've got key points every pi over 8. And again, I don't want to put numbers on all of those necessarily, but at least let me put a hash mark every pi over 8. And 4/8 makes pi over 2. So again, my reader looking at this can say, okay, 4 hash marks makes pi over 2. Each hash mark makes a quarter of pi over 2, pi over 8. We're going to be bouncing around between 1 and negative 1. And let's graph these things. So at 0, I get out 0. At pi over 8, I get out 1. At pi over 4, I get out 0. 3 pi over 8, 3/8, I get out negative 1. At pi over 2, I'm back to 0. 5/8 pi, I'm up to 1. And 3/4 pi, I'm back to 0. And without even writing these, I think you've got the pattern here. You went middle, high, middle, low. Middle, high, middle, low, and then middle. How about back here? At negative pi over 8, I'm at negative 1. At negative pi over 4, I'm at 0. Again, look at my pattern going this way. High, middle, low, middle, high, middle. And once you've got your pattern, you know you're supposed to get this wavy thing. You can graph that. So now we've been able to graph. We've got 3 out of the 4 parameters covered. We've looked at A, we've looked at B, and we've looked at D. The trickiest one is C, and that's coming up next.